So another benefit of the high temperature capacitors we're going after is to combat some of the more extreme conditions the environment is throwing at us right now. So as the summers in Texas are getting warmer, or the winters in Florida are getting colder, you need materials that can hold up to some of those extreme conditions. Also, as military or the US expands into areas that are warmer, or parts of the world are developing that have warmer climates like the Middle East, they have higher requirements for exposure to temperature that are limiting right now the lifetime of capacitors and how long they can run some of their electronic devices before they fail. So the ability to add 20, 30 degrees C operation temperature bandwidth on these capacitors can really open up markets and applications where right now they're using an inferior solution that costs more, is bulkier, and doesn't have the lifetime that we can provide.
Using our LDF film has considerably higher thermal stability. So in the US, there are significant issues right now with electric grid stability in areas with extreme temperature swings. So if you take, for example, in Texas, there's been a lot of issues with stability of the grid. With our LDF film, you have 30 or 40 degrees higher thermal stability. So you can use that film in the capacitors in your substation to make sure that you don't have the sort of failures that you're seeing now.
So when we talk about Nanoplex LDF, or low dissipation factor, it's a capacitor film that does two fundamental things. One is it's very, very high temperature tolerant. So when we look at new infrastructure that needs high temperature, whether it's step up, step down for the power grid, whether it's mobile power distribution, they're looking at very constant delivery of power at a very, very high temperature range, which we give that capability in our product. The other is that because it has this high temperature tolerance, it also has much longer lifetime in the field.